Let's deal with some problems regarding subtraction of fractions. So Anne bought 8 and 3/5 meters of cloth. It was cut from a bolt of cloth 25 and 1/2 meters long. How much cloth remained? So this is a problem that involves subtraction of fractions. So before we go to this problem, let's try to look into the different methods on how to subtract fractions. So there are different cases that involve subtracting fractions. So the first case is subtracting similar fractions. So this is quite similar to the addition of fraction wherein the fractions or the denominators are the same. So when you have this example of subtracting fractions, like if there is a given like 15 over 18 and we are subtracting this to 10 over 18, all we have to do is to simply subtract the numerators and then add the common denominators because they are already similar. So as you notice, 15 over 18, the whole thing is divided into 18 parts, and the same thing here, it's 10 over 18. So the number of equal parts a certain object is divided are actually the same. So there is no need for us to make them similar fractions. So when you have this 15 minus 10, that will simply give us an answer which is 5. And you have 18, you just have to copy. So our answer is simply 5 over 18. And then let's try to investigate or evaluate the numerator and the denominator if they are divisible by a common number so that we can reduce if there is any number that can divide them. So 5 and 18 are relatively prime. So therefore, we have 5 over 18 as our final answer. Okay, so these are again similar fractions. Now, what if there are whole numbers which are involved and still we are dealing with similar fractions? Let's say, for instance, 5 and 3 over 7, and we are subtracting this to 2 and let's say, for instance, this is 5 over 7. Okay, so this is now an example of a fraction wherein the denominators are still the same, so we may say that they are still similar. Now, if you are going to check on this, the problem comes in when you are going to subtract now the 3 and the 5. Okay, because we cannot subtract 3 and 5. Definitely that will give us an answer which is negative. Okay, because 3 is smaller than 5. This is a problem which will involve regrouping. That means there is a need to borrow from the whole number which is actually existing. Okay, so we have 5. And since we need to regroup, that means to say there should be 4 plus 1 plus the 3 over 7, which is actually the fraction which is involved here. So again, the 5 is now renamed as 4 plus 1. That is basically the 5 thing that we are dealing with. And then 3 over 7, we still have it here. And then, of course, the 2 and 5 over 7. So our subtrahend here, which is 2 and 5 over 7, has to wait for the proper minuend. Okay, because as I have said, we cannot subtract the 3 and the 5. That will give you a negative result. So what are we going to do? There is a need for us to change this one into an improper fraction. Okay, we are going to rename this whole number now in terms of the denominator 7. Okay, so this simply means that the 4 will stay because that is now the number when added to 1 will give us the 5. But there is a need for us to rename this one, okay, in terms of the denominator 7. Now, why are we choosing 7? It's because we have the denominator being 7, so we want to get a certain number which is already similar to it. So instead of having or retaining that 1, we will rename that as 7 over 7. Okay, again, if you come to think of it, 7 divided by 7 is equivalent to 1. So we are not actually changing the value. We are just renaming this whole number now in terms of a fraction. So again, 7 over 7 is 1. 1 added to 4 is the same number as the 5 that we have in the given. And then this has to be added, of course, to the existing fraction which we have, which is the 3 over 7. And then after doing that, you have to subtract now 2, 2, and 5 over 7. So to finally find for the answer, we need to combine this first. Using now our knowledge on addition, we have here, of course, the 4. Okay, 4 and the 7 and the 3 now will be added. That will become equal to 10 over 7. And we need to subtract the existing subtrahend, which is now 2 and 5 over 7. So this is similar to the rule wherein you have to subtract the whole number. So subtracting 4 and 2, the answer that we will be getting is 2. And then, of course, you have the numerators, 10 minus 5. That will give us a 5. And the 7 will just have to be copied. Okay, so these are possible problems that may arise when you are adding similar fractions or subtracting similar fractions, I should say. Okay, what about if there are cases wherein the things that we are subtracting are the similar fractions? So let's have some examples for that. So we already know that when we are speaking of the similar fractions, the denominators are different. So for example, you have 7 over 9, and we are subtracting this to, let's say for instance, this is 1 over 5. Okay. So as you notice, the first one, 7 out of 9. So the division here, or the thing, was divided into 9 equal parts, while the other one is 5. Okay, so the division is not the same, or the sizes, if you may have that. Now, if you have this, again, the method is to find for the LCD. So it's similar to the method that we have in addition. So here, 9 and 5, if you are going to look into it, 9 and 5 are actually numbers which are relatively prime. There is no number that can divide both 9 and 5, okay, except 1. So in that case, we can simply find for the LCD by multiplying the two numbers. Okay, again, that happens when you cannot divide the number by the given numbers by a common number. So therefore, 9 multiplied by 5 is equal to 45. Okay, so there is a need now for us to rename again our fractions in terms of the denominator, 45. So the rule is still the same. We have 7 over 9, and we are looking for equivalent fractions in such a way that the denominator is 45. Okay, so there are again two different methods. You can have the cross multiplication, meaning you have to multiply this and then divide by 9, but that is quite longer. So it would be better if you just divide this, the denominator, so 45 divided by 9. the answer is obviously 5 times the 7, that is equal to 35. Again, 35 over 45 is equivalent to 7 over 9, because as you notice, when you divide 35 by 5, it results to 7, and 45 by 5, it results to 9. Again, we call them equivalent fractions. So we have now a value for 7 over 9, which is equivalent to it, and that is 35 over 45. Okay, and the next thing here is the 1/5. So again, 1/5 will have to be equated to a certain number with the denominator of 45. So again, the rule is you divide and then multiply. Okay, so dividing now 45 and 5, the answer is 9. Multiply it by 1, so the answer is obviously equivalent to 9. So again, the 1/5 is equivalent to 9 over 45. So we will now change the 1/5 to 9 over 45. So our aim, which is to make them similar fraction, is already solved. So therefore, we just have to follow the rule wherein we are just going to subtract the numerator. So subtracting 35 and 9, the answer that we will be getting there is 26. Okay, and then you have the denominator, which is 45. So we just have to copy. Now, if you are done with the answer, you try to investigate also or evaluate. Is there any number that can divide 26 and 45 so that we will be getting the lowest term? Okay, no. So there is no lowest term for, this is already the lowest term. So the answer for 7 over 9 minus 1/5 is simply 26 over 45. Now, if there is a whole number, let's say for instance, we have a 9 here, okay, and then this one is 7, we simply have to add those also, the numbers. We have here the 9, okay, so again, that does not change. Only the fractional part will change, but the whole number does not. So subtracting now 9 and 7, so 9 minus 7 is equivalent to 2. So that will be added to the answer, okay, because of the existence of the whole number. So that is how you deal with improper fractions. Again, you need to find for the list's common denominator and then rename to make them similar fractions. And then after translating them or changing them to the equivalent fraction and making them similar fractions, you could just apply now the rules on subtracting similar fractions. Okay, let's have another case. Okay, subtracting whole numbers and fractions. So we have to be careful with this case because it will make a lot of difference. If you have a whole number subtracted from a fraction, and when you have a fraction subtracted to a whole number. So let's take, for instance, look at this. When you have, for example, 35 and you are subtracting, let's say, for instance, 7 and 11 over 20. Okay, and then another scenario could be like this. Let's say, for instance, you have 7 or 17 and let's say 3 over 7, and you are subtracting 5. Okay. So these are two different cases that involve subtracting whole numbers and fractions. So the first one is a mixed number subtracted from a whole number, while in the second one, we have a whole number subtracted from a mixed number. Okay. So do not be confused because this will be following different rules. Remember, when you have 17 and 3 over 7 minus 5, the only concern that you will be having here is the whole number. So 17 minus 5, we don't have any problem because there is no fractional part in 5, which means that this will simply be equivalent to 12 and 3 over 7. Okay? So 12 and 3 over 7 is already the answer. So as simple as that. Because if you are going to check by the opposite operation, we could just add the 12 and 5. That is equivalent now to 17 and the 3 sevens, which is actually the existing fraction. But this one, this is a different story. Because in here, there is a need for us to regroup. Okay, so like in the case a while ago, wherein you cannot subtract the fraction. Okay, so this one has to be renamed in such a way that you will be having 34 plus 1. Okay, but we need to rename this one in terms of another fraction again. So 7 and 11 over 20. Okay, so the one here will have to be renamed in such a way that it will be a fraction, okay, which is equivalent to 1. And since we want to work with fractions which are similar, we will be choosing the denominator which is already existing in the subtrahend. Okay, because for that one, we can actually have 2 over 2, 3 over 3, 4 over 4, 5 over 5, because all of those are equal to 1. But since our aim is for them to be equal or to be similar fractions, we will be renaming that one that we borrowed from the 35 to 20 over 20. Okay. Again, 20 over 20 is equal to 1. 1 plus 34 is 35. We did not change the value of 35. We just rename it in terms of a mixed number. So we have now, you just have to copy this, 7 and 11 over 20. Okay. So we have now the whole numbers, 34 and 7. So we only have to subtract that. 34 minus 7 is equal to 27. And you have to subtract the numerators. So we have 20 minus 11 is 9. And of course, we copy now the common denominator, which is 20. Okay, again, this involves whole numbers and fraction. If you have a whole number subtracted to a mix, there is a need to regroup. But if you have a mixed number subtracted to a whole number, all we have to do is to deal with the whole number. So we simply subtract that and copy the fractional part. Okay, so those are now the different cases that involve subtracting fractions. So for now, we are going to go back to the problem that we had a while ago. So Anne bought 8 and 3/5 meters of cloth. It was cut from a bolt of cloth 25 and 1/2 meters long. How much cloth remained? So the operation that is involved here is subtraction. So again, the problem is 25 and 1/2, and we are going to subtract that to 8 and 3 over 5. Okay, so 8 and 3 over 5. So let's investigate. Oh, you have noticed that the denominators are different. You have 2 and 5, which means that we have to rename this two fractions so that we will make similar fractions. So having 2 and 5, So 2 and 5, if you are going to find for the LCD or the least common multiple, you will notice that there is no common factor for them except 1. Therefore, since they are relatively prime, you multiply them. That means the answer that you will be getting there is 10. Okay, so it's just proper that you will be having now your 1/2. Okay, and we are going to equate that to a denominator of 10. So what should be the numerator now, so that 1/5 will be equivalent to blank over 10. Again, the rule, we have to divide and then multiply. So the answer that you will be getting there is 10 divided by 2 is 5 times 1 is 5. So 5 over 10. And then 8 and 3 over 8, that is now, let's just get the fraction. Okay. So we have again the denominator of 10. So the equivalent of 3 over 10, you divide, that's 2. 10 divided by 5 is 2 times 3 is 6. So this is now 6 over 10. Okay. So after that, we can now go back to the problem. So we have 25, and instead of writing the 1/2, we will be having 5 over 10. Okay, and then instead of 8 and 3 over 5, that becomes now 8 and 6 over 10. Okay, so let's try to check on the fractional part. We have 5 minus 6. So there is another problem again that arises here, because we cannot subtract 5 and 6 because it will give us a negative answer. Therefore, there is a need for us to regroup. So when you regroup, or you have to borrow from the 25, making that now 24. Okay, and then we are going to make that one, okay, the one that we borrowed will become 10 over 10. Why? Because we want them to become similar to it. So 10 over 10, we are going to add actually 10 plus 5 there. Okay, and then over 10. The shortcut for that is actually adding the numerator and the denominator. Okay, so 10 over 5 is equal to 15 minus 8 and 6 over 10. Okay, so we have now the answer for this one. You have now 24, and this is equivalent now to 15 over 10, and we are going to subtract 8 and 6 over 10, and therefore the answer that you will be getting is, subtracting 24 and 8, we will be getting 16, and subtracting 15 and 6, the answer is 9, and we copy the denominator, which is 10, and we have to copy also the unit of measure. So the answer for this problem is 16 and 9 over 10 meters. That's how we deal with subtraction of fractions.